Assalamu alaikum, grade 6 students. In lecture number 5 we will do atoms, chapter number 5, atoms, molecules, mixture and compounds. And what interesting things today you're doing to do is separation of the constituents of a mixture. You know very well that matter can be pure or mixture. Pure substance can be element whose atoms are same, or can be compound whose atoms are different. But in mixture there are two types. Mixture can be homogeneous or heterogeneous. Homogeneous, for example, air, fresh air. Heterogeneous, when air is having smoke particles. Mixture consists of two or more elements or compounds or things which are mixed together in a way that can be separated easily and that are not combined by a chemical reaction. For example, air is made up of oxygen, nitrogen and other gases, ink, water and various dyes. Gunpowder is made of potassium nitrate, carbon and sulfur. Baking powder is made of sodium bicarbonate and tartaric acid. Crude oil is made of petrol, kerosene oil, diesel oil and other hydrocarbons. There are some mixes shown at the bottom of this picture. Milk, lemonade, petrol and soda are the mixtures. Okay, the components of mixture can be separated easily. There are the techniques which are shown in your books on different pages. Filtration is explained. Filtration is the separation of mixture in which the mixture is heterogeneous, means one thing is insoluble. The insoluble thing can be removed by filter paper or by some layers of gravels, anthracite, sand and troughs. These type of techniques are used in filtration plants and in the water filter reservoirs of water supply of any country, any city, or even in car, or even at your home, from where you are taking water, from where you are collecting water for your usage. During filtering, the mixture is poured into a filter paper held in a funnel. The insoluble particles stay as residue on filter paper and the filtrate is obtained in beaker as is shown in the diagram. The impurities, whether it is in the impure water, whether it is in the impure oil, or whether it is in anything, can be removed easily by this simple technique. At page number 51, evaporation is explained. The solution containing the dissolved salt, the solute, is poured into a evaporating basin and heated gently. Eventually, all the liquid, the solvent, evaporates, leaving the salt behind. The salt forms crystals in the basin. This is called evaporation. Salt from seawater can be separated easily by this technique. Mostly in labs, this diagram is shown for evaporation. At page number 52, the separation technique that is explained is sublimation. Sublimation is a property of any solid which turns directly into gas without going through liquid stage. It is mostly happening in iodine and in dry ice. What is dry ice? Solidified carbon dioxide gas. If these type of substances are present in any mixture, this technique can be used. In this technique, what we do, we have some impure, for example, impure iodine crystals. We can place them in an evaporating dish and cover them with coarse filter paper. A funnel is inverted over the filter paper and crystals. When the basin is heated gently, the iodine gives off purple vapor which soon touches the cold sides of funnel, filter paper and turn back into solid iodine. If any pure substance is there, its boiling point is its integral property. This property can be used in distillation. Distillation is the process in which we take a mixture and boil it. The boiling point of different things in a mixers will be different, and this difference of boiling point can be used in separating the components of a mixture. For example, in oil refinery we use this technique. The crude oil is a mixture. It is not much used until its components should be separated by an oil refinery, like the one in this picture. At the refinery, the crude oil is heated. Each part of the mixture boils at different temperature. The part which has the lowest boiling point boils first and is collected from the bottom of the column. The part of the mixture with the highest boiling point boils at the last and is collected from the top of the column. This type of distillation is called fractional distillation, and the topper is called fractionating topper. Page number 53, another technique is used and explained, that is called paper chromatography. Paper chromatography is mostly done for the dyes and separation of their components. In ink and dyes, different drops of inks, different mixtures of inks and brands are used. These brands can be separated easily. Two ways of chromatography are shown here. In one way, a circular filter paper is used. A dot of ink is put in the center. The ink from felt tip pens works particularly well. The wick is bent down into a beaker of water or some other solvent. The solvent soaks up the filter paper, and the constituents of dyes or brands move. This movement, this solvent front, their flow is different, and the difference of flow can be used to separate them. Second method uses a rectangular filter paper. A pencil line is drawn at the bottom with 1 centimeter distance. Spots of different inks are placed along this baseline. The filter paper is rolled and put into a beaker. Solvent moves up, carrying the ink dyes with it. Each different dye will form a different band and will stop at a different point. You can then compare an unknown ink to known inks to see which one it is. This is a very good technique, and this is called paper chromatography. To wrap up, we can say that heterogeneous compounds can be separated by sedimentation, filtration, magnetic separation, and homogeneous mixtures can be separated by evaporation, by distillation and sublimation, and by chromatography. These are the definitions also explained here. Now we will do question number 9. Question number 9 is related to our body composition. Our body is made up of atoms and elements. Here in question number 9 it is told, the table below shows the elements that are making a typical human body. Element is calcium, carbon, chlorine, hydrogen, magnesium, nitrogen, oxygen, phosphorus, potassium, sodium, sulfur. The symbols are also shown and their weights are also shown. There are 4 questions which we have to solve. Ready your journals with blue pen, blue marker, pencil, and be ready and write your work very neatly. Question number 1 is, which 3 elements does your body contain most of? Second is, arrange the elements in order of size with the largest mass at the top. Then we have to sum up all the elements masses. Then we have to take out the percentage of body mass. The answer of 9th A part is oxygen is 44 kg, carbon 12.15 kg, and hydrogen 6.75 kg. 9B part is elements in decreasing order of mass: oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, potassium, sulfur, then sodium, magnesium, and chlorine. C part is total mass of body is 67.39 kg. 9th third part is the actual sum of all the atoms combined and added up. Now, fourth part of ninth question is the percentage of body mass consists of non-metals. So we will collect all the non-metals mass and then we will divide it by total mass. We get 97.51 kg. It means that most of our body is made of non-metals. In wrap up, we have done 5 separation techniques: filtration, evaporation, sublimation, distillation, and chromatography. Thanks for watching this video. Allah Hafiz.